Hello everyone, I'm Paul and today we're solving problem 3370, smallest number with all set bits. This is easy and next I will show you how to solve this step by step. If you are just learning binary numbers, this is an interesting one. We are given a positive number n and we need to return the smallest number that's greater or equal to n and contains only set bits, meaning bits that are 1. Let's say n is 5. Remember that 5 is the base 10 representation of the number and the base 2 representation is 1, 0, 1. This is position 0 and this corresponds to 2 to the power of 0. Position 1 corresponds to 2 to the power of 1. Position 2 corresponds to 2 to the power of 2. And this might continue, okay? So, to build a 5 in base 10, we need 1 2 to the power of 2, this is 4, and we need 1 2 to the power of 0, which is 1. 4 plus 1 is 5, and that's how we reach 5. So this is the base 10 representation, this is the base 2 representation. We need to return the smallest number that's greater than or equal to 5 that has only set bits, meaning bits that are 1. And here we have a 0. So the result in this case is we just put 1 here. And this in binary is 7 because we have 1 2 to the power of 2, meaning 1 4. We have 1 2 to the power of 1, meaning 1 2. And 1 2 to the power of 0, meaning 1 1. And 4 plus 2 plus 1 is 7. So in this case, we return 7. And there are different possible solutions for this. We can iterate every number from n to 1024, which is 2 to the power of 10. And this is the maximum number we can have because n is 1000. So first we try 5 and the binary representation of this is 101. Next we try 6. The binary representation here is 110. Next 7. And the binary representation here is 111. And as soon as we find a number that's greater or equal to n and has all set bits, we return the corresponding number. So in this case, we return 7. But today we are using a different approach. We will try every number with only set bits from 1 to n. And as soon as we find a number that's greater or equal to n, we return that number. So first we are trying this number, meaning 2 to the power of 0, and this is 1. 1 is smaller than n, so we continue. Now we try this number, and this is 3. 2 to the power of 1 plus 2 to the power of 0, meaning 2 plus 1. This is 3. And 3 is smaller than n, so we continue. And now we are trying this number, meaning 7. And 7 is greater than 5, so we just return 7. And maybe you are wondering, how can we iterate numbers with only set bits? Meaning first we are here, then we are here, then we are here, and so on. How can we represent this in base 10? Well, first we start from number 1. This will be our current value, x. We start here. And now if we want to move here, we just do 1 times 2 plus 1. And this is the trick. The result for this is 3. And 3 in binary is this. And now we repeat the process. We do 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. And 7 in binary is this. So we are doing the same every time. We do x times 2 plus 1. And the result is the new number. If we do 7 times 2 plus 1, the result is 15, meaning this in binary. Remember, this is 2 to the power of 3. So the key here is to understand this. Once you get the theory, you can implement different solutions. And with this in mind, let's go with the code. The code is very short. Remember, we are iterating numbers with only set bits, meaning bits that are 1. First, we start from 1, and now while x is smaller than n, we move to the next number with only set bits. And for this, we do x is x times 2 plus 1. Finally, now x should be greater or equal to n, so we return x. This is the entire code. Now let's submit this. As you can see, this works and it's very efficient. Time complexity here is big O of log n and space complexity big O of 1. This is it for this problem, so if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.